Okay, for today's lesson, we're continuing on with the gas laws, and once again, you'll need your calculator. Okay, so combined gas laws. So what if you wanted to talk about pressure, volume, and temp? So we're going to have all three of these. So in essence, we're combining Boyle's law, Charles' law, and Gay-Lussac's law into, it's called the combined gas law. And it shows the relationship between pressure, volume, and temperature of a fixed amount of gas. So we're not changing moles. That is going to stay the same. Some of our problems will say the gas is at STP. So if you'll recall from earlier in another chapter, we said that STP stands for standard temperature and pressure. Standard temperature is if we're assuming the gas is at 0 Celsius, which is the same as 273 K, and standard pressure is at 1 atmosphere or 760 millimeters of mercury or 760 torr, whichever one of those relationships we'll be talking about. And you can use STP to compare volumes of a gas. Okay, so your formula is going to be P1V1 over T1 is equal to P2V2 over T2. So this is your initial conditions of pressure, volume, and temp, and these are your final conditions of pressure, volume, and temp. Just like we did earlier, we're going to cross multiply to simplify this to be able to get an equation we can work with. So it's going to be P1V1 T2 is equal to P2V2 T1. Okay, that makes it easy for us to manipulate to come up with an equation to work with. All right, so your first problem says given 20 liters of ammonia gas at 5 degrees Celsius and 730 millimeters of mercury, calculate the volume at 50 degrees Celsius and 800 millimeters of mercury. So I'm going to have to work these on another sheet because I did not leave myself much room to work. Okay, in essence, it does not matter which is your initial set and which is your final. So I'm just going to say 20 liters is my initial volume. So my V1 is 20 liters. And the temperature that's at is 5 Celsius. And if you'll remember, you've got to convert that to Kelvin. So you're going to add 273. So that should be 278 Kelvin. And the pressure that this gas is at, initial pressure, is 730 millimeters of mercury. Okay, we want to know our new volume. So volume 2 is your question mark. If we change the temp to 50 Celsius, so temp 2 is 50 Celsius, add 273 to that. That's going to give you 323 Kelvin. And we can use our pressure in millimeters since this is in millimeters. So we're going to say our new pressure is 800 millimeters of mercury. Okay. So if we have P1V1T2 is equal to P2V2T1, we're wanting V2. So we're going to divide both sides by P2T1. So our manipulated formula is going to be V2 is equal to P1V1T2 over P2T1. So all we've got to do now is plug in our numbers. So our initial pressure was 730 millimeters of mercury. Make sure you put your units. Times our initial volume, which was 20 liters. Times our new temperature, which is 323 Kelvin. We're going to divide that by our new pressure, 800 millimeters of mercury. And divide it by our initial temp, which is 278 Kelvin. Okay. Millimeters of mercury will cancel. Kelvin will cancel. We're left with liters. So we're simply going to say 730 times 20 times 323. Divide that by 800. Divide that by 278. And you should get 21.2 liters. Okay, now if we go back and look at our problem, I probably didn't have the best problem here because this only has one sig fig, so we're going to change this to one sig fig. So I'd write down 21.2 and then equals to 20 liters. Okay, so when you do it to correct number of sig figs, your volume didn't change. So that's why I'd go ahead and show the 21.2, but then show your final answer is 20 liters. Okay? Okay, your next one. To what temperature must 10 liters of nitrogen gas at 25 Celsius and 700 millimeters? So I'm going to call this my initial condition. So I'm going to say my volume 1 was 10 liters. That temp was 25 Celsius plus 273 is 298 Kelvin. Okay, and then that pressure was 700 millimeters of mercury. We want to know our new temp, that's your question mark. And our new volume is going to be 15.0 liters. And our new pressure is 760 millimeters of mercury. Okay, so we want T2 this time. So if we have P1 V1 T2 is equal to P2 V2 T1, and we want to solve for T2, we're going to divide both sides by P1 T2. Okay, so excuse me, no, V1, sorry about that. So it should still be here, T2. There, get that straightened up. Okay, so we're going to say temp 2, I've got this all messed up, don't I? Temp 2 is equal to pressure 2, volume 2, temp 1, divided by pressure 1, volume 1. So pressure 2 was 760 millimeters of mercury. Volume 2 was 15 liters. Temp 1 was 298 Kelvin. Divide that by pressure 1. Goodness. Pressure 1 was 700 millimeters mercury. And volume 1 was 10 liters. Your liters will cancel, millimeters will cancel. So we're going to take 760 times 15 times 298, divide that by 700, and divide that by 10. So it should give us 485.3 Kelvin. We're just going to leave that in the calculator because we want it in Celsius, so we're going to say minus 273. And so it gives us 212 degrees Celsius. And 700 is 1 sig fig once again. So if we do it to 1 sig figs, we would say 200 degrees Celsius. So I probably should change and put a decimal here so we have 2 sig figs, but nonetheless. Okay, our last problem says the volume of a gas-filled balloon is 50 liters, so that's my volume 1 is 50 liters. And my temp 1 is 20 Celsius, which add 273, that's 293 Kelvin. And my pressure 1 is 742 millimeters. And we want to know our new volume if our gas is at STP. So if you remember, if it says STP, you do know another temperature and pressure, so we're going to say our temp 2 is 0 Celsius, which is 273 Kelvin. And our pressure 2 is, since this is millimeters, we'll use the 760 millimeters of mercury. Okay. So we're looking for volume 2. So volume 2 is going to be P1 V1 T2 divided by P2 T1. Okay. So pressure 1 is 742 millimeters of mercury. That volume is 50 liters. Our temp 2 is 273 Kelvin. Divide that by pressure 2, which is 760 millimeters of mercury. And temperature 1 was 293 Kelvin. Okay. Kelvin cancels, millimeters cancels. You're going to be left with liters. So 742 times 50 times 273 divided by 760 divided by 293. So our new volume is going to be 45.48 liters, and 20 Celsius has 1 sig fig, so this is your first sig fig. Next door, this is 5 or above, so we're going to round that to 5, so you're going to say 50 without a decimal, 50 liters. Okay, so that is combined gas loss. So this is the formula you'll use, P1 V1 over T1 is equal to P2 V2 over T2. If you are dealing with initial set of pressure, volume, and temp, and going to a new set of any one of those. Thank you. Now you can complete your homework set.